So for the first part of video homework, let's talk about problem 1 in homework 10. So problem 1 is not an ordinary homework. It's a little bit weird, so I'm not sure how to do this, but let's try. So first we have to talk about the Poisson process and all the related things about Poisson process. So the first thing is the definition of Poisson process. The definition of Poisson process is that x0 should be 0 and xt1 minus xt2 should be a number of let's say calls received in t1 and t2. So, and the probability or the density function of this is xt1 minus xt2 equals k. K is the calls received in t1 and t2 equals e to the minus lambda t1 t2 and k. Okay, and there are some properties like the expectation of xt is lambda t, and the autocorrelation is lambda t2 t1 t2. Oh, this should be t2 plus lambda minimum of t1 and t2. And the covariance of t1, t2 is, there's no plus here. Okay, and it's the correlation minus, this is the correlation minus expectation of t1 and t2. The product of two expectations, so it should be the lambda minimum. Should be the lambda minimum t1 t2. Okay. So the second thing we want to talk about the Poisson increments. So the definition of Poisson increments is that is yt equals epsilon xt plus epsilon minus xt. Okay, and also the probability of yt equals epsilon n is probability times yt equals n. Okay, expectation of yt. Expectation of x which is epsilon times, and the correlation this is under the condition that t1 minus t2 is smaller than epsilon, and this is under the condition that t1 minus t2 larger or equal to epsilon. And the covariance t1, t2 is 0, epsilon. Okay, and we still have 5 left. And the third one we're going to talk about is Poisson impulses. So first, let's think about the definition of Poisson impulses. It is the t derivative of xt. xt is the Poisson process, okay, so which is the limit of yt when epsilon is close to 0, right? So, and right here xt is a Poisson process. Yt is a Poisson increment process. The expectation of zt is lambda, and the correlation t1, t2 is lambda t2 plus lambda t1 minus t2, and the covariance t1, t2, lambda t1 minus t2. Okay. So, and then the fourth one is semi-random telegraph signal. So we define this semi-random telegraph signal in this way. Xt can be 1 or minus 1 under the condition that k is even in 0 to t, and k is odd in 0 to t, and the probability of n t1 t2 equals k is e to the minus lambda t k lambda t k. Okay. And I think we have similar questions in previous homework. So we can know that the probability of xt to be 1 and the probability of xt to be minus 1. So it's just two parts of the how to say that, of a Poisson process. Yeah. So from the homework before, p xt that's it. And the expectation of xt, it's obvious, just 1 times the probability of xt to be 1, and the minus 1 times probability of xt to be minus 1, and that's the expectation, which is e to the minus 2 lambda t, and the correlation is e to the minus 2 lambda t1 minus t2, which is tau, right? Tau. Okay, covariance t1 t2, correlation minus expectation, right? So t1 plus t2, right? It's the product of two expectation. Then let's talk about the fifth one, random telegraph signal. Random telegraph signal. The definition of this random telegraph signal is strongly related to the definition of semi-random telegraph signal, right? So, for example, let's say xt is a semi-graph or semi-random. Semi-random telegraph signal. Yeah, that's it. And A is a random variable independent of xt, and the probability of A to be 1 equals the probability of A to be minus 1, which is 1/2. And we define yt equals A times xt as the random telegraph signal. And the expectation of yt is the expectation of A times the expectation of xt, which is 0. And the correlation is e to the minus lambda 2 lambda t1 t2. Covariance, really correlation minus expectation, which is e to the minus 2 lambda t1 t2. Okay, that's all about problem 1.